Hello, knowledge seekers. In this episode of 20-Minute Books, we delve into The Disordered Mind by Eric R. Kandel. This enlightening book offers a window into the complex interplay between neurological disorders and the mysteries of the human mind. Drawing from a lifetime of groundbreaking research, Kandel, a Nobel Prize-winning neuroscientist, illuminates how afflictions such as depression, schizophrenia, and addiction not only disrupt our lives, but also provide invaluable insights into the mechanisms that govern our thoughts, emotions, and behaviors. As we explore disorders of the brain, we gain a deeper understanding of the most enigmatic aspect of our existence, the consciousness. Kandel's expertise and accessible writing style make this a compelling read not only for armchair philosophers and hobby psychologists, but also for anyone touched by neurological disorders, such as Alzheimer's. This book is a must-read for aspiring neuroscientists or anyone fascinated by the puzzle of consciousness. So join us in unraveling the mysteries of the mind with Eric R. Kandel as your guide in the disordered mind. The Disordered Mind. What unusual brains tell us about ourselves. Introduction. Discover the brain's intricacies through its anomalies. Have you ever pondered the marvel that is the human brain? A complex and intricate organ, the brain governs not only our rational thoughts and conscious actions, but also our subconscious quirks. Sometimes, we gain the most profound understanding of this magnificent organ by examining its malfunctions. Imagine a sophisticated computer system. When it glitches, we dissect the problem, which in turn reveals the intricacies of its design. This is what happens when we study the brain through the lens of disorders and abnormalities, understanding the brain by its disorders. The study of the brain has undertaken a fascinating journey since Philippe Pinel, often regarded as a pioneer of psychiatry, laid its foundation in the 18th century. Confronted with the many puzzles of mental illnesses, researchers have learned to read these disruptions as a map leading to the deeper mechanics of the mind. Like a detective, modern neuroscience uses these clues to unravel the biological bases for our emotions, thoughts, and conduct. Thanks to the advent of advanced technologies, our exploration into these disordered minds has achieved unprecedented depth, providing valuable insights. This journey binds the domains of biology, psychology, and neuroscience, allowing us to comprehend our brain's functions through the lens of disorders like autism and its effects on social behaviors, schizophrenia and the nexus with creative thinking, Alzheimer's disease and its impact on memory, and much more. Key takeaways from neurological deviations. Throughout this exploration, you'll uncover some transformative revelations, such as the correlation between a key brain chemical and the connection between seemingly disparate conditions like schizophrenia and Parkinson's disease. You'll delve into the reasons behind addiction being classified as a chronic disease rather than a mere lapse in willpower or moral failing, and perhaps most intriguingly, we'll examine how much of our lives are governed by an unconscious mind, operating below the radar of our awareness. These insights provide not only a compass to navigate through the complexities of neurological disorders, but also a mirror reflecting the fundamental nature of our being. Part 1. Decoding brain function through the looking glass of mental disorders. Picture a day filled with intense emotions and thoughts, a roller coaster of highs and lows that everyone rides occasionally. Now, imagine this ride doesn't stop. The lows are abyssal and the highs skyscraping, affecting every aspect of life. Welcome to the world of mental disorders, where the ebb and flow of mental activity isn't just part of living, it's a torrent that disrupts it. The core idea here is that examining brains that function differently can provide clarity on how a typical brain operates. This exploration of mental science began in earnest with Philippe Pinel, who revolutionized the understanding of mental disorders in the 18th century. He posited that the roots of these disorders lay in the physical realm, within the brain's structures. Now, we're armed with the knowledge that a disorder of the mind is, fundamentally, a disorder of the brain affected by genetics, external factors, or injuries. Before we delve deeper into this topic, let's establish a foundation. Imagine the brain as a city with millions of inhabitants, neurons, forming complex networks similar to roads. These neurons communicate ceaselessly, sending electric impulses and chemical messages known as neurotransmitters across synaptic highways. When a section of this network misfires or stalls, the result can be a mental disorder. The field of modern neuroscience is now investigating the whys and hows behind neuronal misbehavior. By genetically tweaking mice, scientists can observe the consequences of specific genetic changes, elucidating disorders like Huntington's, a one-gene anomaly, or depression, with its convoluted genetic and environmental interplay. Furthermore, cutting-edge imaging, such as functional magnetic resonance imaging, fMRI, provides a dynamic look at the brain's live action, highlighting active areas through their oxygen use. These tools have set neuroscientists on a path to illuminate the functioning of a healthy brain by examining its opposite. Part 2. Autism sheds light on the brain's intrinsic social wiring. Imagine possessing a silent power that grants you a glimpse into people's thoughts and feelings, a kind of mind reading that's second nature. This isn't the stuff of fiction. It's a fundamental skill most humans develop as their brains evolve to navigate an intricate social world. By age 3, children typically grasp the concept that others possess distinct minds, filled with thoughts and emotions unique to them. This realization, known as theory of mind, is central to predicting and understanding the actions of those around us swiftly and effectively. But for some, like children on the autism spectrum, this process is neither simple nor instinctive. Autism demonstrates how our brains are hardwired for social interaction. Autism, which presents in early childhood, is a developmental disorder affecting an individual's abilities in social interaction and communication. The autism spectrum is broad, with varying degrees of impact, but commonly, individuals with autism find it challenging to decipher others' thoughts and feelings, struggle with language acquisition, and may not respond as expected in social settings. Children with autism often show a pronounced preference for solitude and a heightened sensitivity to changes in routine. They tend to engage in repetitive play and may exhibit extraordinary talents in specific areas such as mathematics or art. These characteristics are linked to differences in brain development, where some areas may not mature in typical fashion, while others could mature early to counterbalance. Leslie Brothers of UCLA's School of Medicine discovered in 1990 that the disrupted brain regions in children with autism encompass those associated with emotions, language, communication, but also with vision and movement. Brothers proposed the existence of a social brain, a network finely tuned to processing human-related information. The social brain's underdevelopment hinders autistic individuals from effectively forming a theory of mind, complicates communication, and reduces facial and movement recognition. Brain imaging shows that, for someone with autism, the experience of watching a person moving isn't significantly different from observing the motion of clock hands. However, in neurotypical development, observing any human motion instinctively triggers the social brain. Through the lens of autism, we gain a remarkable perspective on our social brain's inner workings, highlighting the critical role it plays in our everyday lives. Part 3. The interplay of chemistry and emotion in mood disorders. Emotions color our existence, weaving through the fabric of our daily life, guiding our connections, desires, and decisions. However, when our emotional compass is thrown off balance, it can lead to profound distress, manifesting as mood disorders like post-traumatic stress disorder, PTSD, or depression. These are not uncommon afflictions. They touch nearly a third of Americans at some point, emphasizing the need to unravel and address them. Mood disorders arise from chemical imbalances in our emotional control center. Within the myriad of emotions we experience, a handful are foundational, deeply embedded in our brain's architecture, evolutionarily wired to ensure survival. Take the instinctual fear that shoots through your veins at the sight of danger. It's a primal reaction, bypassing any rational analysis to facilitate immediate action. Emotional reactions can be innate or acquired. A mouse, for instance, may come to associate a particular sound with discomfort, learning to fear the sound through repeated exposure. This example illustrates how our brain, once it has forged a connection, clings tenaciously to these emotional pathways, complicating the treatment of mood and anxiety disorders. The regulatory hub for our emotional repertoire is known as the limbic system. This network includes the hypothalamus, which marshals physical responses, the racing heart, the sweaty palms, and the amygdala, a modest-sized but mighty structure deep in the brain responsible for sparking our initial emotional reactions. In individuals grappling with depression, PTSD, or anxiety disorders, the amygdala and hypothalamus are notably hyperactive, their chemical messengers thrown into disarray. For example, research links all these disorders to excessive levels of cortisol, the stress hormone, culminating in altered sleep patterns, energy fluctuations, and appetite changes. A deeper understanding of antidepressants offers insights into chemical correlations, showing that those dealing with depression and anxiety typically have reduced levels of serotonin. This neurotransmitter, a chemical conduit for neuron conversations, plays a pivotal role in a broad spectrum of brain functions, from emotional regulation to thought processes, and from learning to memory. Part 4. Tracing the impact of schizophrenia on the brain's cognitive and creative circuits. Schizophrenia remains one of the most misunderstood and stigmatized mental health conditions. Its reach across various brain regions leads to profound alterations in cognition and behavior, which can be challenging to comprehend for those on the outside looking in. Individuals with schizophrenia often grapple with hallucinations and delusions, which can include hearing voices or possessing strong convictions of being targeted or receiving veiled signals. However, schizophrenia's influence extends beyond these pronounced symptoms to subtler issues like social withdrawal, diminished drive, and memory deficits. Schizophrenia's wide-ranging effects on the brain entail thought, memory, and even creativity. This mental disorder is associated with abrupt changes within the brain, especially during the critical period of adolescence. Synapses, the bridges that facilitate communication between neurons, undergo a natural pruning process to refine the brain's efficiency. In those with schizophrenia, this pruning happens excessively, disrupting the maturation of key areas, such as the prefrontal cortex, which is crucial for complex planning, and the hippocampus, the seat of memory. Genetics appears to play a significant role, with studies pinpointing variations of the C4 gene in many with schizophrenia. This particular gene marks which synapses should be pruned, and when overactive, can lead to the severing of an overly large number of these essential connections. Dopamine, a neurotransmitter with a broad portfolio that includes influencing thought, memory, emotion, and behavior, is also central to schizophrenia. An abundance of dopamine is characteristic of this disorder, adding another layer to its complexity. One of the more enigmatic aspects of schizophrenia is its association with extraordinary creative output. The influence of schizophrenic art stretches back to Cesare Lombroso's pioneering compilation in the 19th century, which later inspired avant-garde movements such as Dadaism and Surrealism. The nexus between mental disorders and creativity is a recurring theme throughout history, underscored by the many creative geniuses who battled mental illness, from the frenetic narratives of Jack Kerouac to the vibrant torment in Vincent van Gogh's paintings. Current hypotheses suggest that mental disorders may intensify creativity by easing the usual restraints on thought processes, allowing a more profound engagement with the unconscious. While definitive explanations remain elusive, The link illustrates an intriguing silver lining to conditions like schizophrenia, highlighting an expanded cognitive vista where the typical borders of thought are reshaped. Part 5. How protein malfunctions undermine memory in degenerative brain diseases. The saga of Henry Molaison, or HM as he was known in medical circles, offers a window into some of neuroscience's most profound discoveries. HM's story is a bittersweet one. After a childhood accident led to severe epilepsy in his later years, a drastic surgical intervention alleviated his condition, but at a steep cost. HM lost his ability to form new memories, while his ability to recall long past events remained intact. Intriguingly, he retained the capacity to learn new motor skills, albeit without any recollection of having acquired them. Faulty proteins gradually dismantle explicit memory in Alzheimer's and dementia. HM's case highlighted the existence of two distinct memory processes in the brain: explicit and implicit memory. Explicit memory, which encompasses the remembrance of events and personalities, relies heavily on the hippocampus, which was compromised in HM's surgery. The hippocampus is also critically implicated in Alzheimer's disease and dementia, the most prevalent neurodegenerative conditions that ravage memory. Unlike HM, whose memory deficit owed to surgical intervention, individuals with Alzheimer's or dementia suffer from the deleterious effects of dysfunctional proteins. Let's delve into the world of proteins for a moment. Typically, proteins meticulously fold into elaborate shapes necessary for their function, fitting precisely into brain receptors as a key fits into a lock. However, in the brains afflicted by Alzheimer's and dementia, proteins misfold, aggregate, and transform into what scientists refer to as prions. These errant proteins generally first manifest in the prefrontal cortex and migrate toward the hippocampus, initiating a gradual breakdown in neuronal communication and ultimately leading to neuronal death. As disheartening as these conditions are, the insights gleaned from memory disorders propel understanding forward. The recognition of prions and their role in Alzheimer's and dementia not only clarifies the pathways leading to memory erosion, but also paves the way for potential therapeutic strategies. Each discovery, each piece of the puzzle, brings us closer to comprehending and hopefully mitigating the impact of these memory-stealing diseases. Part 6. Unraveling the connection between brain chemistry and motor function in Parkinson's. Our intricate brains harbor a myriad of proteins, each with the potential to either contribute to vital bodily functions or, if improperly folded, lead to disruptive neurological conditions. Parkinson's disease, alongside Huntington's, exemplifies how misfolded proteins can slowly undermine an individual's control over their own movements. Parkinson's disease casts a spotlight on the significance of brain chemicals in facilitating movement. The smooth coordination of muscles that enables us to move effortlessly is a well-concerted interaction managed by our brain. An elaborate motor system of neurons spans from our brain to the muscles throughout our body, directing movements and providing sensory feedback. However, in Parkinson's disease, something interrupts this harmonious neural dialogue, culminating in the recognizable tremors and the diminishing range and speed of motion that typically emerge around the age of 60. Initially diagnosed by the eponymous British doctor in the 19th century, Parkinson's was not immediately recognized as a brain disorder due to its overt physical presentation. Advances in the 20th century identified a key brain area involved, the substantia nigra, noted for its dark coloration in healthy individuals, which appeared significantly lighter in those affected by Parkinson's. This region dispatches neurons that produce dopamine, a critical neurotransmitter for controlling movement. In stark contrast to schizophrenia's dopamine surplus, Parkinson's is marred by a dopamine deficit. The insidious protein alpha-synuclein, when misfolded, causes disruptions in the substantia nigra. Research on fruit flies has linked the misfolding to mutations on the SNK gene, though the origins of these mutations remain enigmatic. Initially, neurons in the substantia nigra kick into overdrive to counterbalance the functional decline, but they are eventually overwhelmed and destroyed by accumulating protein clumps, leading to dopamine scarcity. Dopamine not only stewards movement but also the precision of motor control, explaining the tremor and the gradual erosion of motion seen in Parkinson's patients. This neuronal loss is also why the substantia nigra loses its dark hue in those living with Parkinson's, reflecting the disease's progressive grip on the brain. Part 7. The relentless grip of addiction on the brain's reward circuits. Not long ago, the prevailing belief was that addiction boiled down to a deficiency of willpower, that an individual simply had to choose to break the chains of destructive habits. But as neuroscience peels back layers of the brain's mysteries, a far more complex picture of addiction emerges, one that shows it as a profound alteration of the brain that goes beyond mere choice. Addiction seizes control of the brain's reward system, with effects that can linger indefinitely. At the heart of our ability to savor pleasure is the brain's reward system, a neural network centered around dopamine, a neurotransmitter associated with gratification. This system encompasses the dopamine-fueled corridors of the substantia nigra stretching into the hippocampus, amygdala, and striatum, centers for memory, emotion, and habit formation, respectively. The reward system's primary role is to encourage pursuits that release dopamine, thereby teaching the brain to seek these experiences. Enjoy a delicious banana, and your brain's response, a gentle flood of dopamine, makes you more likely to reach for one again. But not all rewards are created equal. While a banana may trigger a mild dopamine response, habit-forming substances like cocaine elicit much more dramatic releases. Far from a simple release, these substances also tamper with the normal processing of dopamine, prolonging its effects. The reward system etches into our neural pathways not just the sensation of the drug, but also the accompanying environmental cues, faces, places, even specific tunes connected to use. For someone with an addiction, encountering triggers can activate an overwhelming quest for pleasure, driven by the brain's reward mechanism. And current research suggests these associations are enduring, potentially embedded in the addicted brain for life. It is this tenacity that results in high relapse rates among those in recovery, leading specialists to approach addiction as a chronic condition that requires ongoing management rather than a one-time issue to solve. Part 8. Exploring the spectrum of sex and gender through brain and body development. The dance of nature has choreographed a complex interplay of biology and identity within the human species, forging an array of behavioral patterns that extend beyond the binary division observed in most animals. Men and women can indeed exhibit differences rooted in their biological framework, yet human variance in gender expression outstrips that of any other species. There is a myriad of biological expressions when it comes to sex and gender identity. Intriguingly, scientists have unearthed subtle yet distinct variations in the brain structures and molecular activities of men and women, mapping areas that govern not only reproduction and sexuality, but also emotional expression, memory processing, and stress responses. Deciphering how these cerebral patterns influence our thoughts and behaviors is an ongoing puzzle, but evidence suggests that notions of sex and gender do indeed find representation in our neural pathways. Diving into the specifics, the relationship between the sex assigned at birth, based on observable genitalia, and one's gender identity is anything but linear. For instance, an individual with female genitalia might identify as a man. To further enrich the narrative, there are 3 discernible variants of sex: anatomical, determined by external features; gonadal, dictated by hormone-producing organs; and chromosomal, rooted in our genetic inheritance. Developmental twists start taking shape in the womb, where the presence or absence of a Y chromosome can direct the growth of either testes, which release a surge of testosterone, or a default pathway toward female anatomical traits. Shortly after birth, there's another hormonal wave that imprints on the infant's brain, seemingly cementing certain gender-linked behavioral propensities. Yet it's fundamental to recognize that for many, these anatomical, gonadal, chromosomal, and identity pieces all align neatly. In others, a web of complexities emerges due to variances in development timelines, encompassing a spectrum of disruptions and permutations. For example, gene mutations can disrupt the expected alignment of anatomical sex with gonadal and chromosomal sex. Women with the CAH gene, for instance, experience higher testosterone levels in the womb, which is more typical of male development. This condition correlates with higher instances of bisexuality, homosexuality, and transgender identity among such women, underscoring the significant role of hormones in shaping identity. Part 9. Peeling back the layers of consciousness with neuroscience. Consciousness stands as one of the most enigmatic and captivating constructs of the mind, an intricate tapestry weaving together our awareness of thoughts, sensations, and feelings. At its core, being conscious equates to a real-time awareness of our internal and external experiences. It's the difference between merely processing stimuli and being able to reflect on the sight of a friend, the scent of a rose, or the flush of fear. Neuroscience has made strides in decoding the enigma of consciousness. Scientists now understand that our overall consciousness is tied to the brain's degree of alertness. For instance, when we're engaged and awake, our brains buzz with activity, slowing down as we sleep and quieting further in states like comas. Evidence from animal studies indicates that the brainstem plays a pivotal role in modulating consciousness. Damage to this area can plunge mice into a coma, while stimulation can interrupt slumber. Contemporary neuroscientists have also begun to map out the specifics of conscious experience, identifying the precise moments when we become aware of particular thoughts or perceptions, as well as the brain regions responsible for them. This research validates some of the early insights from the psychoanalytic luminary Sigmund Freud, affirming that the mind operates on both conscious and unconscious levels, with the latter exerting significant influence over our attitudes and actions. Cognitive psychologist Bernard Baars introduced the global workspace theory to explicate why certain mental phenomena break into consciousness while others remain in the shadows. According to this model, beneath the surface, our brains are always processing sensory information, largely outside of awareness. It's only when we focus on a particular item that the initial sensory input is elevated, broadening into the expanse of consciousness, the global workspace. In experiments where images are shown too briefly for conscious recognition, the brain's visual cortex activates momentarily and then subsides. Yet, when the exposure extends, that visual spark doesn't fade, but instead propagates, resonating across multiple brain regions and entering the realm of conscious perception. As neuroscience continues its quest, leveraging cutting-edge tools and interdisciplinary synergy, it may inch ever closer to demystifying how our brains conjure the profound phenomenon of consciousness. Final summary: mental disorders, ranging from autism and schizophrenia to depression and Parkinson's, are not mere afflictions, but open doors to understanding the intricate machinery of our minds. These conditions reveal the profound interplay between brain structure, chemical messengers, and our resulting thoughts, emotions, and behaviors. Each mental disorder is characterized by specific alterations within the brain, underscoring the delicate balance that dictates our cognitive and emotional experiences. Whether stemming from anatomical irregularities, as seen in autism and schizophrenia, or from disruptions in the brain's chemical dialogue, like those at the root of depression and Parkinson's, the common thread is the transformation of the neural landscape. Genetics and environment interweave to shape the onset and progression of these disorders, offering invaluable lessons about the ordinary functioning of our brains. As we deepen our understanding of these conditions, we edge closer to unraveling the complexities of the human mind, its vulnerabilities, and its incredible resilience. Thank you for joining me today on this journey of learning and discovery as we explored the insights of another thought-provoking book in our growing library of knowledge. If you've enjoyed our time together, please take a moment to follow our podcast, give us a 5-star rating, and share 20-minute books with other knowledge seekers. Your support truly means a lot. Don't forget to join me again in the next episode, where we will delve into another enriching book. Until then, happy reading and happy listening.